When the Schwarze Pumpe power plant was built south of Berlin in 1998, it was the biggest lignite-fired power plant in the world. It provides electricity for 2 million households in Germany, but in the process spews out 10 million tons of carbon dioxide every year. CO2 from burning fossil fuel plays a major role in warming the Earth's temperature. An increase in carbon dioxide in the air prevents heat escaping into space. Instead, it warms up the planet. So what would happen if this carbon dioxide could be somehow captured before it could escape to do its damage to the environment? That's exactly what engineers and scientists from the Vattenfall energy company are planning to do, with what's known as carbon capture and storage.
Carbon capture and storage is an idea of capturing carbon dioxide from a coal-fired power plant, transport it and safely store it deep underground. The idea of storing carbon dioxide underground was born from the knowledge that these kind of formation have been able to store natural gas and oil for millions of years, and that was how it was born. And we know today that we can do this safely.
Vattenfall is building a small-scale experimental power plant at Schwarze Pumpe, which will be CO2-free. The carbon emissions will be captured while the coal is being burnt. In a process called Oxy Fuel Combustion, oxygen rather than air is used during the burning of the lignite or brown coal. This produces flue gases made up of steam and a high concentration of carbon dioxide. The CO2 is then purified and compressed and transported by pipeline in liquid form, a concentrated version of the carbonated water that we drink, to be stored deep underground. This is a carbon storage research site backed by the European Commission at Ketzin, to the east of Berlin. The technology used is not new. It's been employed for decades by the oil and gas industry. Experts agree that the best places to investigate for commercial-scale storage are depleted gas fields where the geological formations are well understood. Here they're drilling 800 meters down to beneath where natural gas was once stored and will begin injecting CO2 into the porous sandstone next year.
For the storage, you need two different types of rock. One is the actual storage stone. For this purpose, sandstone is ideal because it doesn't react with CO2 and is often highly porous. The CO2 is actually stored in the pores of the sandstone. The rock above is also very important, which acts as a cover, a cap rock, and that must be gas-tight.
When carbon dioxide is injected into the sandstone, the carbonated water is heavier than the water around it, so it sinks to the bottom of the porous rock, and the CO2 is trapped indefinitely. The scientists here at the Geosciences Research Center are studying the effects of storing millions of tons of CO2 underground. But as carbon dioxide occurs naturally in geological formations, they believe it's far safer in the ground than in the air, where it's producing worrying changes to our climate. Since 1990, the world has seen the 12 hottest years on record. Polar ice caps are melting and sea levels rising. At their spring summit in Brussels, the leaders of the 27 EU member states agreed a landmark package of energy and climate proposals. They committed to limit global warming to no more than 2 degrees Celsius above pre-industrial levels. They called for developed countries to cut greenhouse gas emissions by 30% compared to 1990. If there's no global agreement, the EU has pledged to take the lead by reducing its emissions by at least 20% by 2020. Ambitious targets not achievable without new technology, such as carbon capture.
It's likely to be quite important because in Europe, for instance, the electricity producers, European electricity producers, they've estimated that carbon capture and storage could be playing up to 40% of the reduction effort that we're needing up to 2030. And globally, in particular countries which are using a lot of coal, like the United States and China, carbon capture and storage is likely to be a very important part of their portfolio of fighting against climate change.
Carbon capture is exciting the minds of policymakers and scientists around the world. Experts from the United States were in Brussels in May for a transatlantic exchange of ideas and views on best practice and to discuss a regulatory framework for future use of the technology.
You have to understand, it isn't just significant for global warming purposes. There's an energy security aspect to this. Coal is a very abundant resource, and mostly in friendly country hands, whereas oil, for example, and 90% of the world's reserves are in not friendly hands. So coal is a resource we want to be able to use. If it can be done cleanly, it's perfect.
Out in the North Sea off Norway, a gas field run by Statoil was the first place in the world to operate carbon capture and storage on a commercial basis. Since 1996, CO2 extracted from gas production at the Sleipner field has been stored 1,000 meters below the seabed instead of being released into the air.
We have removed 1 million tons of CO2 from the atmosphere every year. That is a sizable and important amount. But secondly, even more important in my opinion, is that we have shown that storage is safe, that it can be technically done in a good way, and we've opened the doors, if we can use that expression on a platform, to all the world to come and see.
Statoil says theoretically there'd be enough room to store the emissions from all the power stations in Europe in this gas field for the next 600 years. And experts say there are huge numbers of suitable sites onshore, around the world, to store millions of tons of CO2. They dismiss suggestions that it's playing with nature.
Whether we erect wind turbines or exploit oil, gas or coal, in all these cases we influence nature. We've gained 30 years' experience in the storage of gas, methane, natural gas or town gas in underground storage, which is a similar setup to the CO2 storage we're talking about now.
In countries undergoing massive industrial growth such as China, there seems little doubt that this promising technology could be of critical importance in dealing with greenhouse gases. China is hugely dependent on fossil fuels. It's likely to soon overtake the US as the world's biggest producer of CO2. The European Union has signed a partnership on climate change with Beijing, which includes a commitment to transfer carbon capture technology to China. But critics worry that the expansion of renewable fuels and energy efficiency will be pushed into a back seat if too much emphasis is put on carbon capture. The EU says it should be part of a policy mix, a battery of measures to reduce greenhouse gases. The fight against climate change should be fought on as many fronts as possible, and carbon capture should act as an important bridging technology while other energy solutions are developed.
It's very seldom that you're having new challenges which are then mobilizing the regulators both sides of the Atlantic as well as industry. A very energizing industry to do things which they haven't done before. It's a little bit like sending people to the moon. It's something which is new, they haven't done before, and it's getting quite a lot of people from very different parts of the world actually cooperating, and therefore I'm very optimistic about its future.
There are several carbon capture and storage projects underway in Europe. The challenge is to refine the technology to make it affordable on a commercial basis. The EU hopes that more than 90% of coal-fired power stations will be fitted with the technology by the middle of this century. Another huge advantage of capturing carbon is that it reduces air pollution too. Sulfur dioxide emissions can be cut by up to 75%. Nitrous oxide and particulate matter also reduced by significant amounts. The EU is making available up to €400 million for research into this sustainable use of fossil fuels, in particular clean coal and carbon capture and storage. When the storage begins here in Germany next year, it will be another step in the low-carbon revolution.